Okay, now that we've got the differential apart, we can see, first of all, here's our caging bolt. You see it's backed off there, and there's the end of it sticking through right here. And so when we wind that caging bolt in, it actually pushes right here on this big lever, big arm, okay? So it pushes here and pushes against these pivot points. You'll see there's a pivot point up the top here, pivot point at the bottom on bearings, and it actually pushes on this little leg here, this lever, okay? And if I move it out of the way, we can see how it pushes on this pin and this pin here. There, so when that is pushed around like that, we can see it's pushing against those pins which are spring loaded. That's our spring that applies the brake when there's no hydraulic pressure. So that pin and that pin push against this big lever here. Now, if we look here, we'll see that in that lever, there are these two holes. Now, they're very, very close to the pivot point, but not right exactly on the pivot point. They're just off center. So we get the mechanical advantage of the spring pushing way out here on this lever. So here's our force, here's our fulcrum, and there is where our load is. Okay, so we got this big lever, force applied by the spring, this big distance here, and the little distance, fulcrum to our load right there. So when that spring pushes, it actually puts a great deal of force, much more than the spring pressure because of the mechanical advantage, on this pin and this pin, and forces that plate against the little tiny return springs we have there just to keep the brakes from dragging, pushes on that plate and applies these discs. Okay, so that's how the spring applied parking brake works on this inboard disc brake. In order to take this brake apart, if we want to check it or service it, first of all, I've marked the plate for orientation, so it's facing up the top, which is where we marked the differential before already when we took it apart. And you can see I put X's here where the pistons push on the plate. We already saw how the spring pushes on the plate using these pins and that lever that's inside the other part of the differential. Okay, so the spring applies the brake using these two pins, but hydraulically the service brake is applied by pistons pushing on these three spots equally spaced around this big disc. So we use the same disc, we just apply it differently. Okay, so once the spring has released, this plate will move back this way because these little return springs will help push the plates back. Once our spring is released, that's what happens. And if we look here inside our differential, we can see the three hydraulic pistons that apply the brake when we step on the brake pedal, the service brake. So spring applies, okay, through this lever, but once the brake is released, the spring pressure is released, we have to hydraulically apply the brake when we step on the brake pedal for our service brakes. And if we pull one of these pistons out, we'll see the big hole, and you see the chamfer on the edge so that it doesn't damage the seal when we put the piston in. And we'll see the piston itself, and there's our seal ring. Okay, so if that seal ring fails, then hydraulic oil is going to leak from our brake system into our differential, and that'll be a problem. And when I push this piston back in, a little harder than it looks but for one hand, so I push it in, and here is the hole that supplies the oil from our brake pedal. When we step on the brake pedal, supplies that high pressure oil to apply these three pistons. So there's going to be internal cavities drilled through that housing to supply hydraulic fluid pressure to all three pistons simultaneously. Now, if we look at our parking brake, there's our piston, okay? Our piston right here and our piston right here that is spring loaded right now. In order to release that spring pressure, we have to apply hydraulic oil through this port. So there's the service brake port, there's the spring brake release port, and when oil is supplied there, if we look carefully, it's lined right up with our piston, with our spring. It is actually going to be applied to this side towards us of that piston, and it's going to hydraulically push the piston back that way against spring pressure and release the spring pressure. Okay, we can see the passage that supplies oil through there to the other piston as well. So both those pistons are released with hydraulic pressure, pushing against the spring, and then our service brake is applied with hydraulic pressure when we step on the brake. So I've just about got these bolts backed out. There's 1, 2, and 3 here. These 3 bolts are what hold this plate in position. And I've just about got it removed, but I wanted to show you, now that I've taken a lot of the tension off, we can see how that plate is spring loaded. Those springs behind the plate are always trying to release the brake for us. So when there's no hydraulic pressure applied from the service brake and no spring force applied from our parking brake, that plate is released with, a reasonable amount of spring pressure, so these discs don't drag and cause our plates to wear out when the brakes are not supposed to be on at all. Now our plate is removed, and we can see that those bolts are shouldered bolts, and the spring fits over our shouldered bolt, okay, like so, and it actually fits into a slot, as we can see, so that the bolt head can hold the plate, and the spring can be on the other side, like so. Okay, so when it's installed, it looks like that. Okay, so here we have our brake discs, and what we'll notice is we have a friction disc, and it has splines on the inside, and that friction material all the way around the outside circumference, because that's when we're going to get the most mechanical advantage, the most braking torque, if we put our friction material as far away as possible from the center. Okay, so there we go. That's our friction disc, and of course it's got friction material on both sides and the splines on the inside, so it's going to grab a hold of the shaft. Okay, now the very next plate is what we call a steel plate, or a reaction plate. That plate, as you can see, is open in the center and got little lugs or dogs around the outside that engage into the differential housing. So if we were to lock this friction plate, okay, together with this steel plate by clamping them together, by squeezing them like this, squeezing them together, then we're going to lock our splined shaft to our splined steel discs, which are locked to the case. And that's how we stop the axle from turning.